today from 1:30.
Testing, testing, 1, 2, 3. This will be on theories of perception.
Hi, Lizard. Is this your one-on-one?
And I can also do Wednesday at 3:30 except
Thank you.
for that's like what I'm working at. But Alfred sometimes I can I was like, oh, it's that.
I have a meeting at 1:30. You said you're free from now.
Yeah, do you want to?
Yeah, we can do that. Okay.
Do you want me to do it in Alfred or?
Why don't we? Because I need to get back to the meeting. What do I need you over there?
Yeah, that sounds good. I'm going to run out.
Okay.
I have one question.
Yes.
When kids add like an extra E in the past tense word, like 5-year-old building.
Building? Yes.
Like, is there a name for that?
Yes.
What is that?
Well, typically it's over-regularization. Words that are irregular. So you might say random. So you're marking it 3 times. Because you get the rule, but you don't know when to use it or when not to use it.
Yeah. So that's not what we're doing our project on. Though, I babysit too. So we were watching them run, and our project we were like, how the little ones run, little snippets of it all, and like, why are they doing that? I don't know if it's ecological, it's definitely ecological.
It is actually psychology. It's actually learning about this.
How are you, Jess?
Well,
Okay, thanks.
But you can certainly do
like, oh, when do they stop
when do
doing
they
that?
do it and when do they stop it.
That's our project. But you ruined me because now I'm babysitting and watching all these kids. Two separate.
Oh, just wait.
2 separate 5-year-olds in 2 separate houses. So it's like
Random. Maria Veronica used to say, had chicken. You didn't see I had chicken, because they get the rule, and then they have to figure out what not to use.
So
It's over-regularization, but when it is an irregular form.
This is developmental for babies.
Angel.
I call it, in my head, I'm calling class babies in my book.
Babies. Oh, babies as well.
And then babies research.
There you go. Babies research. Did you see that picture?
I saw it. That was crazy. I sent you an email saying I hope that my 80-year-old parents are not on that staircase.
Right? Well, my name for that was Bad Stairs.
Bad Stairs. Wow. Thank you. That will be used in this class, but thank you.
I saw that and thought of you.
Yeah.
It was like 45 degrees. I don't know what to wear. Like I hate when like the in-between days of like in-between, like not quite summer and not quite fall, like cold in the mornings but hot in the afternoons. It's the worst. Thank you. Yeah. I completely zoned out.
yeah.
I don't really know how that went.
Yeah.
And usually I just like assume the worst.
Yeah.
Like I probably stumbled over my words like all the time and
No, I know. I always think maybe that's something too.
yeah. Oh. I was like, yes, early. Don't have to worry about it anymore.
Right.
I don't know what everybody expected of you. Yeah. I used some of the ones that are like in shared the past years, and I was like, okay, so I found one that was like really sparse and one that was like really detailed. And I was like, well, okay, somewhere in between these two would probably be good, so that's what I tried to do. Yeah, I'm like Yeah, that's the problem, because I like, when I have too many TED-Eds, I forget like which one's about what. Yeah. Like, I don't know. One of the TED-Eds they did this.
Do you, I know that you have other classes with me. Do you do them for other professors too, or am I the only TED-Ed?
No,
Okay.
only one.
Okay.
Only
That's right. For some of you, that's true, right? Now, I've been told that some high schools are using TED-Eds and other K through 12, but I wasn't sure how many people around Denison are using them.
So far with this, there's nothing get mixed up. Extreme systems. Oh, this was the one where I was like, wow, this was extreme systems.
Yeah, there's a lot of extreme systems over that. This is great.
Yeah, I was like, yeah, the first question I was like, I can answer this without the wiki. That's good. That makes me feel good about myself.
One thing that I remember from history. The rest of it, not so much.
Yeah.
You know why?
So I'm going to IT after my meeting for senior research, and yeah. And so I'm gonna like go to this meeting and be like, look, I have all this stuff on my computer for this, and I don't have it really anything on it.
Oh yeah, because you literally can't log in or anything.
Yeah, I can't log in, which is the worst part.
I hate when something on your computer goes wrong and like that is my life.
Yep, that's what everything is.
And I don't have a backup either. The hard drive is probably backed up. I mean, Facebook stuff. Like 4 years later, so yeah, no, I haven't. I'm just like, but a lot of the time, I know. A lot of things I'll say well myself, but I really break them down. But like on my laptop, I have the folders for every class, and exactly not everything. So it's like everything's organized on the laptop.
Yeah.
Oh, okay. I have the worst on the computer, so it's really frustrating. Deal with another error. Yeah. Probably like.
That's really weird because the caps lock key works and the tab key works, but no other key works. Like none of the letters and things. And I'm like, what are you doing to me?
Yeah.
Like I can't, because my other computer, like even if the keyboard stopped working, you can still log in because I have like the fingerprint. Oh yeah. But this one doesn't have that, so I can't even log in. Yeah. So yeah. Don't get password.
I changed it and I didn't realize it changes it every like tomorrow.
Okay.
Hi. Hey.
No, I didn't do it. That's like a good bit. I remember your meeting. It's ingrained in my head. So
Yeah, same. Yeah.
Okay, we've got 12:30. Why don't we get started? Good afternoon, S&P. Wow, that sounds like a pretty good response, given that it's a Monday, and welcome to the beginning of our full week number 3. A couple of announcements today. First, congratulations to all of you, and thank you for an excellent session the other day on student-generated topics. Those were really good, and we flowed one right after the next, and when somebody was up here trying to get their video going, people were really good in keeping the conversation going. People were jumping in and responding to other questions. I've had a few years where a student will say something, and it just falls flat, and then the next student says something, and that falls flat, then there's a really long pause, then a third student says something, and that falls flat. You do a really good job of keeping the conversation going, so thank you for that. I look forward to having many more of those throughout the semester, and those are going to be listed, of course, on the syllabus. Okay, so great news, as I've said before. The news around here just keeps on getting better. We have the exam coming up. Okay, so we have our first exam coming up on Friday, and this is available to you out on the S Drive and also out on Blackboard, so nothing new here. Here's something about the format, the content, and how to practice. And we mentioned that this was worth a small fraction of the points. It's like the TED Ed questions are small fractions. Everything in our semesters is always low stakes so that we can ramp up rather than taking big steps upward. Okay? So that's available to you, and I'll give you one more reminder about that on Wednesday. Okay. While we're talking about Wednesday, I just thought I'd mention that we do have the final TED Ed before that exam will be on Wednesday. For today, you finished a TED Ed on theories of perception. And just for a little bit of context there, we started out doing the issues of consciousness in the beginning of our semester. Then we thought about things like how do we measure consciousness. And after about 150 years of psychophysics, and psychophysics is about that old, it's one of the older branches of our modern psychology. After about 150 years, we have lots and lots of data. So we need theories of perception, and some of these are more viable than others, but we'll be talking about those today, and we'll also be talking about those on Wednesday. So we'll do Theories of Perception Part 2. Okay? A couple of other announcements, just so that we're all on track. I won't see many of you in the room until Wednesday again. I'll see a few of you in the 1:30 class if you're taking the research class. But just to give you a heads up, we are delighted here in the department to welcome Dr. Maureen Craig, who's coming to us from OSU. She's a social psychologist. You may have seen the posters around the fourth floor here, but really interesting work on the changing demographics in the country, and she looks at attitudes, looks at political attitudes, social attitudes, and how those might be changing when we come to what we might call a majority-minority country. Who's heard of that expression before, a majority-minority country? Okay, the idea being that we have, in the next couple of decades, we'll have people who have historically been viewed as minorities actually making a numeric majority. Okay, so that should change attitudes, we think, and her research will be on that. So that's going to be 4:30 tomorrow at Higley, and I hope, if your schedules allow, you'll come out and join us. One more announcement. Today at 4:30, I'll be back in this room giving an overview of the neuroscience concentration and other kinds of neuroscience activities. Okay? All right. Any questions on any of that organizational stuff? Okay, somebody's got something going. I hear something clicking back. Said yours? Okay. Heard some kind of a... Oh, is that that? Is that my own thing here? Oh, that's me. I got something going. I'm looking around and I'm localizing it out there. Okay. All right, so a ton of those coming up. Okay. All right, so let's take our 2 steps forward and 1 step back. Just to begin to review, we do have the test coming up, and we do like to distribute our practice, okay? Can somebody remind us, when we were talking about consciousness, what is the hard problem of consciousness? The hard problem of consciousness. This was given to us by a philosopher named David Chalmers. The hard problem? Okay, Connie's got something.
Trying to explain or being able to put like emotions to something, so where I forget the phrase, but like where the neurology part meets emotion.
Okay, right. Where does the neurology part meet the emotions part? That's a very nice way of stating that, okay? How do we go from firing to a feeling was one of the questions, right? So that's an interesting philosophical problem. Of course, some people think it really isn't a problem, right? There are some folks who, like Gerald Edelman, thinks it's really not a problem. Does anybody remember Gerald Edelman's response to that hard problem of consciousness? Yeah, okay, thanks, Zach. Okay, right, the explosion does not resemble the explosive, so we don't typically have the cause and the effect physically resembling each other, so why should we expect it in this case? But in any event, it certainly is true that there is a relationship between this set of ions flowing through us and the very subjective experiences that we have. Okay? So that was, at the ionic level. We can bump it up a level and talk about populations of neurons, and we talked about this thing called neural handshaking and or neural synchrony. First, who remembers that phrase from that conversation? Anybody want to help us out with what that may have meant? Either neural handshaking, or we use equivalently neural synchrony? What's that all about? Okay, Meg's got something.
When several neurons like fire together for you to kind of like recognize, I guess like the stimulus. Like they gave the example of like the blue marker.
Okay.
Like maybe something like a color sensitive neuron reacts to the blue versus like a
another neuron is sensitive to the verticalness of the pen.
Okay.
So both are firing together, it makes a relationship between them.
Excellent. Right. Okay. So we do have neurons that are separated. Some of them are going to be in one location, and they're going to be picking up color information. Others are going to be picking up orientation information. Others are going to pick up shape or size. We'll see that there are some that are tuned to stereoscopic depth. There are cells in your auditory cortex that are tuned to different frequencies, different auditory frequencies. We had a demo on that not too long ago. Okay. So the idea is that they begin firing together, even if only momentarily. Right, even if only for a few hundred milliseconds or maybe a few seconds, as long as the stimulus lasts, those will be synchronizing, and they give, presumably, that would be a neural correlate of consciousness. That's some of the thinking anyway. Okay. All right. So after we had that conversation on consciousness, we moved on to the next couple of days in our course, and we talked about how we make measurements, and we had two predominant measurement systems. Anybody want to remember or remind us what those measurement systems were, or approaches to measurement? Probably the 4th and 5th day of class, or maybe the 3rd and 4th day of class. Measurement systems. Ways of approaching measurement. Okay, thanks.
Are these like the psychometric functions?
Okay, that was one of the two. That was actually the second of the two. We had a whole session on psychometric functions, okay? And we did that one after we did another approach to measuring sensory sensitivity. And what was that called, that other approach? Yes, thanks, Mel. Signal detection theory, okay? And there are a couple of recurring themes between those. We talked about measuring sensitivity, either using signal detection theory or measuring sensitivity using psychometric functions. Anybody want to remind us what went with what there? I mean, how did we measure sensitivity with psychometric functions? How do we measure sensitivity with signal detection theory? Remember what those components were? Okay, thanks, Alexa.
In signal detection theory, sensitivity is measured with D prime.
Okay.
Which is essentially just the distance sort of between the two.
Perfect. Okay.
What are those called?
We can think of them as distributions, right? Distributions of neural activity is what we're modeling there, right? It's a cartoon of neural activity. We can get very quantitative, but we won't. But okay. Huh?
Yeah. And then in psychometric functions, the sensitivity is measured by the slope.
The slope. Okay, really good. So if we have really, really steep slopes, we get a big rise over a relatively small run. We make a mountain out of a molehill if we're very sensitive. Right? Okay, that's the idea. So there's a correspondence between measuring sensitivity in psychometric functions and measuring sensitivity using D prime. There are times when it's more convenient to use one of those two measurement tools. And sensitivity is something that we often want to measure. That's separate and apart from a person's response bias. And can somebody else help us out with what the two indicators were of response bias, one in signal detection theory and one in psychometric functions? Okay, thanks, Nick.
In FCT, was the criterion.
The criterion, okay, which is that vertical line that shifts back and forth between those frequency distributions, okay. Liberals on the left with low criteria, okay, suggests a liberal response bias, okay. Do you remember what the other one was?
Psychometric functions, it was the PSYC, or point of subjective.
The point of subjective equality, right? So we can have a physical axis that ranges from negative values to positive values. On the physical axis, 0 is going to be neutral, okay? It might be the case that a system, like your auditory system or your visual system, or your political system or your judicial system is tuned in the same way that the physical system is tuned, but it might be biased leftward or rightward, and we can quantify those biases using the point of subjective equality. Okay, so that was the idea there. Okay, we had a couple of demos on the point of subjective equality. Anybody want to remind us a little bit about how those went? And on psychometric functions. One of them I did for us, then the next day we had a couple of students demonstrate those for us. How did that go? What kinds of things do we measure? Okay, thanks, Madison. Oh yeah, A, okay, A 440, the A above middle C, so if that would be there, just about over there for you all, okay. Okay, we measured sharp versus flat, high tones versus low tones, and we figured out by using that that psychometric function. We found the best fitting function, and we were able to derive a threshold and a point of subjective equality. Okay. Then we had students do the next day. They were actually running the experiment, and what was the phenomena that we were measuring? The psychophysical phenomena we were measuring. Okay. Yeah. Thanks, Claire.
But like finding where the sound is coming from.
Perfect. Yeah, finding where the sound. Oh, by the way, if on the test you lose a phrase like you can't come up with auditory localization, that's okay. You could say, the thing where we tried to figure out where people were tapping on the board. That's fine. I'll figure it out. Okay. Auditory localization, and we found a threshold there. So those are two very different aspects of our auditory experience, and yet you can begin to see the generalizability of psychometric functions or signal detection theory. We can use this to measure just about anything. And after 150 years or so of psychophysical data, we have lots that needs explaining. And we do this explaining by creating theories that we hope are explanatory. And I'm going to, just for the moment, very unusually, jump to question 13. You don't have to flip through, but question 13 came up a little bit later in your readings for today. But there's something that I guess it was J.J. Gibson was citing in Kafka's work. And this is one of my favorite questions. Why do things look as they do? It's such an elegant question. Right? Why do things look as they do? And of course, we're going to be embarking on visual physiology and visual perception in just a few sessions. But after that, we can do listening, and we can do we can do olfaction and other kinds of senses. So we could reframe that question: why do things sound as they do? Why do things taste as they do? Right? Okay. But that's Kafka's deceptively simple question. Does anybody remember his two broad answers to that question? Why do things look as they do? Okay, Meg's got something.
The first one was they are what they are.
Okay.
And the second was because the proximal stimuli are.
Okay, all right, really good. So there's just a little bit of terminology there, so I'm going to rephrase. That was spot on, okay? Why do things look as they do? One answer to that is because the world is as it is. Okay, it's a statement about the environment. Why do things look as they do? Well, because the world is as it is. Zach looks taller than me because Zach actually is taller than me. Okay, that's why he looks, and I look as we do in our relative heights. Okay, Claudio's shirt looks red. Well, we'll find out it isn't really red, but at least we can say that it's reflecting predominantly long wavelengths. Okay, and when things reflect predominantly long wavelengths, we have this experience of red. That's something about the real world out there, what's being reflected from the shirt. Things look as they do because the world is as it is. Who's following that? Okay. A tuba sounds different from a piccolo because tubas and piccolos actually put out different physical stimuli. They sound as they do because they are physically different. The world really is as it is. Okay? The other half of that, which Meg also correctly put up, is that in answering the question, why do things look as they do, the other kind of answer is because the brain is as it is. So one idea is the world is as it is. The other idea is the brain is as it is. And you can imagine that two organisms can be inhabiting exactly the same environment, exactly the same world, but if they've got very different brains, then you'll probably see that things will look very different to those two organisms. Okay? Or you yourself will have very different kinds of experiences with the same stimulus depending on what we might call the adaptive state of your nervous system. And throughout the semester, we'll have many chances to do all kinds of exercises where we momentarily change the state of your brain and have you look at a stimulus under that condition. Then we let your brain resume to its normal state, and we look under that condition. And we'll see that things do change in their appearance or in their sound and so forth. So why do things look as they do? Because the world is as it is, and because the brain is as it is. Okay? Two ways of thinking about that. So sorry to jump ahead to number 13 there, but that was such a nice framing question. It just happened to come a little bit later in our reading, so I tried to remain somewhat chronological with the way I numbered the questions early on. Okay, I wonder if we might do a couple of TED Ed questions here, and we'll see if we can get maybe people pairing up, and we'll put everybody on all three of these questions. I'll project the questions now. Why don't we do questions 2, 4, and 5? Okay, so these first couple of questions here. And we'll talk a little bit about the structuralists in question 2. In your own words, briefly explain how structuralists approach the study of perception. Also briefly explain what introspection is. Maybe you and your partner can talk about that. When you're done, you and your partner can talk about this. In your own words, briefly explain how Gestalt psychology differs from structuralism. And we'll go as far as number 5. In your own words, briefly explain the Gestalt concept known as multi-stability. Also briefly explain the Gestalt concept known as invariance. Okay, so there's something to chew on there with you and your partner for a few minutes, and then we'll come back and see what we've got. Okay, why don't you find a partner and have at it. It's okay to be in trios, too. Trios are fine.
But I can't access. So, I remember writing about just like things that like thoughts are yeah, these basic like more complex things are just like cherish and 4 or 5. Yeah. So I think that there are a lot of
breaking down the small
we actually experienced how it starts being like the whole that's what we experience. We don't experience it rather than and it's I remember just growing up like basic instead of whereas structuralism our worldviews like I wrote down figure
smaller components
like your
that way. Yeah, so that's what happens is like recognizing that like when you're in rotation, right? Your translation, whatever. Yeah, it's like face. The squiggly one, no matter what interpretation. So yeah. This part is
yeah.
I was like, oh, okay, I can do this. Or at least what we look at. I was like, ours is a robot. Yeah.
Together because they're on the scale versus
Alright, I get it. Yeah, that makes sense. So it's just that like it's hard.
Yeah, it's hard. And then my one
Okay, some of us have made it all the way through, and some of us are still a part of the way there, but that's okay. Wherever you got, it's good to be able to explain this to a neighbor and practice expressing ourselves. At Dennison, we really do like generative responses, and just getting in the habit of expressing ourselves orally and in writing and so forth. So I wonder if we can get somebody to help us out with this idea about structuralists and how they approached the study of perception, and then maybe after you give us that overview, you could tell us a little bit about introspection. Anybody want to take a stab at this? Structuralists. Okay, thanks, Meg. Thank you very much.
So I kind of explained it as if structuralists kind of break down perception into just basic sensations.
Okay.
So it's all different. They look at like the separate, most basic parts to explain, and then for more complex examples, you combine like different, more than one basic sensation.
Okay.
To explain it more complex.
Okay. That's actually excellent. So the idea here that structuralists very much look at the individual elements of perception. One writer had described it this way, that these early psychologists were very much influenced by something like the periodic table in chemistry. And we can come to all different kinds of very complicated chemistries by knowing what the elements are. Okay? So they wanted to break down our perceptual experiences into the most rudimentary sensory components that they could. So if we can think about chemical atoms, right, they would almost have an atomistic view of perception. They would try to break things down into the smallest components, and then if you could somehow add them together, then their summation. They used a fancy word called concatenation, which you won't need to know, but if you've ever worked with computer files, you can concatenate or put two files together. If you have a rudimentary sensation here, and a rudimentary sensation here, and a rudimentary sensation here, you can link them all together, associate them, and the whole will be equal to the sum of the parts. That would be the idea. So you need to know what the parts are, and then you need to sum those up, and that would be one way of approaching the question, why do things look as they do? Well, why don't we break down what's out there in the environment into either simplest elements or simplest sensations and see if we can string them together. And one way of thinking about how they've approached this is that simple phrase, the whole is equal to the sum of the parts. And we need to know what the parts are, and then we string them together. Okay? Which isn't necessarily a bad way to have been thinking about this. As we'll see, there are many limitations associated with structuralism, but that was one of the ways that they began thinking about that. Who's okay with that? I think it's probably best that we started out with structuralists, because we will come back to that many, many times, and that wasn't a bad way to get the ball rolling on this question, why do things look as they do? Anybody want to take a shot at introspection? That was one of their methods. You know, if I really want to understand my most rudimentary sensations, I should engage in introspection, or maybe trained introspection. Anybody want to take a guess at what that? Okay, Sarah, thanks.
It's kind of like a self-report about your feelings or sensations or anything like that. Melanie and I said it's kind of like looking within.
Okay.
Explaining what you're experiencing.
Excellent. It's looking within, okay? And you had another phrase that was great there. A self-report. Yes, a self-report, okay? So this is all done internally, right? So maybe we can sit quietly in a room and focus on the fact, I'll go back to that example, Claudio's shirt is red. If I just think about that redness, and I think about, how am I having that experience? If I meditate on it long enough, I will derive some insight about the most rudimentary building blocks of our perceptual worlds, and I can then string those atoms together, and I can put them all together and sum up to the whole. Okay, all I need to do is introspect. As you might know, this kind of thing drove B.F. Skinner crazy. Okay? If it isn't public and it isn't verifiable and it isn't reproducible, Skinner would have nothing to do with it. Okay? So this more or less has fallen out of favor, but 150 years ago, they were just trying to put it all together, and they were very much inspired by other scientists. They saw themselves as scientists. They were inspired by other scientists. The chemists were able to break down their phenomena into atoms and molecules. Why don't we too take this atomistic approach? Maybe we can get there just by thinking, self-reporting on our most basic sensations. Okay, in the interest of time, why don't we move on? Can somebody contrast Gestalt psychology and structuralism? I want to give that a whirl. Okay, let's go with Claire. Yeah, thanks.
Gestalt psychology is pretty much exactly the opposite of structuralism.
Okay.
It uses all those different parts and the separate atoms and things to combine as a whole and see how they all function together.
Okay, so yeah, so the unit of analysis is very different in Gestalt. Right? What happens is now we're starting with the whole, because the whole is fundamentally different or other than the sum of the parts. Okay? In the structuralist world, if we just knew the parts, we could string them together and we'd get there. But there are these emergent properties. Sometimes you can get, we'll do it this way. Hopefully, you see something of a U shape there, right? What are the elements? circles, okay? And yet somehow, particularly from a distance, we wouldn't see circles. We would say, well, there's a U-shaped function there, right? So there's no U in any one of the elements, and if you added all the O's together, you would never really come up to a U, right? So the whole is different from the components. It's fundamentally different. And so you'd never be able to experience or explain using structuralism this particular configuration, right? The whole is different than its components. And it doesn't necessarily mean it's greater than, it's just different. Okay? It could be greater in some ways, different than, and that's a pretty strong contrast to the structuralist approach. Okay? A moment ago, we talked about the idea that you can think of the structuralists as having these rudimentary elements that are broken down, and then we sum those all together. And their analogy was something like, the periodic element table from chemistry. In Gestalt psychology, they had a very different analogy. They were thinking of something akin to field theory in physics. And in field theory, what's very important is how are things related one to the next. It's very, very relational, and we'll see that later on in James Gibson's writing. These elements have a certain spatial relationship one to the next. Okay? And that's not something that would be captured necessarily in a periodic table or just by the rudiments themselves. You can take exactly the same element and reconfigure their relations, and you'd wind up with a very different stimulus. You'd wind up with a very different perception of that stimulus. Okay, so it's very relational. They're thinking about the field and not just about the components. Okay? All right, so we'll move on from there. I wonder if somebody can help us out with multi-stability, and then we'll come to invariance. Okay, thanks, Alexa.
So metastability, I'm thinking about the image of the vase and the two vases.
Okay.
So it sort of describes that phenomenon in which, like, a stimulus that might be a little bit ambiguous, you can switch back and forth between seeing two things. Excellent.
Okay, so there are these stimuli. Who remembers the face-vase demonstrations? Okay, and there are lots of them. We'll see a Necker cube in just a moment that are said to be multi-stable. You can look at them for a while and you have one pretty clear interpretation. But the stimulus is intrinsically ambiguous. It actually can be perceived many different ways, and across time you typically have almost incontrollably the perception of one state and then the other. And it's really interesting now that we have technologies that can measure brain activity. We do have people self-reporting very subjectively what they're experiencing. Are you seeing the face? Are you seeing the vase? Which of those two? And we can see if there are maybe ERP coordinates of that you get some kind of a shift in the ERP read or maybe in the MRI read as we're toggling back and forth between those very subjective states, trying to tie the neuroscience to the perceptual state. Of course, back in the early days, they didn't have that as a possibility for them. So that's multi-stability. We'll show you an example in just a moment that I think is really, really cool. Before we do that, can somebody help us with the principle of invariance? Okay, thanks, Sarah.
The ability of our mind to recognize the same object despite a change in size or rotation.
Oh, wow. Beautifully stated. The ability to recognize the same object despite a change in size or rotation. Wow, I should write that down. Now, you don't have to get that down, but that's the idea, right? Any variation on that is going to be pretty good as long as you have the main notion that you're able to recognize a given object despite the fact that it's changing. So the object is physically changing, it's physically varying, and yet somehow you still know that even though poor Meg, she sees me from this distance and I get really, really big on her retina, I'm changing dramatically on her retina, and somehow I still look like the same guy. Okay, right? So we're changing the stimulation on her receptors, but somehow she still knows it's me. We've all seen Big Bird on Sesame Street, right? That big yellow bird, and you've probably seen dolls of Big Bird, and you've seen two-dimensional representations of Big Bird. Immediately you know it's Big Bird, even though some of those are 2D, some of them are 3D, some of them are 6 feet big, some of them are this big, okay? They vary dramatically, and yet somehow there is this, if you will, pattern that is Big Bird. And that pattern is, if you will, the invariant, right? It's what doesn't change. In the auditory world, we can think of something that we might know as the Happy Birthday song. And you can hear the Happy Birthday song on a tuba, and you can hear the Happy Birthday song on a flute, and you still recognize it as being the Happy Birthday song. Even though there's been tremendous variance in the auditory frequencies, the fact that there's a pattern there that you can pick out almost immediately suggests that somehow maybe what you're perceiving is an invariant, some kind of pattern that seems to survive despite the fact that there's changes in the physical stimulation. Who's okay with that? Okay? So it's interesting to think about, gee, what do our sensory and perceptual systems do for us. Do they pick up light? Do they pick up sound? Do they pick up frequencies? Or are they picking up invariant patterns, which might be something a little bit higher order, right? There's patterns, and a little bit akin to what we see going on here in the Gestalt world. Right? What's the relation of the first note that the tuba player is playing relative to the second note and the third note? Even though it's a tuba, there's going to be some kind of pattern that we would also recognize in the flute. Okay? So just for fun, you may have seen these, but I think I've got the crazy cube illusion. How many people have seen this one before? The crazy cube? Let's take a look at the crazy cube. Isn't that crazy? Right, if we can freeze it right there, I find that pretty compelling. I find it pretty compelling that there's this thing dangling in the middle of nowhere, right? Okay, and yet when we take the camera on through, you can see how it's all organized. Okay, but the Neko cube, that's this cube, typically is a multi-stable percept. Even if it's not drawn on a wall, just drawn on a simple piece of paper, usually you can see this popping in one direction, popping out in the other direction, and so forth across time. A multi-stable percept. Okay, pretty cool, right? This is what we see, at least from this particular camera angle. Okay, any questions on any of that so far? Our little introduction to Gestalt. The whole is greater, or other than the sum of the parts, and structuralism, the whole is the same as the sum of the parts. Okay, why don't we go back to a few more questions. Okay, and why don't we do it this way? I wonder if somebody would come up to the board, maybe over here, and draw us an example of the Gestalt principle of proximity. People did that out on Draw 2. Does anybody want to volunteer? Maybe we can get one or two volunteers to put one of those there. Okay, thank you. Thanks very much. And then what the rest of us can do is we'll begin pairing up on some other TED-Ed questions. So I wonder if I can have some folks over on that side of the room. Okay, we'll let you find a partner, and we'll have you do questions 9 and 10. Okay, we'll have you work on, in your own words, explain what is meant by the phrase unconscious inference. Also briefly explain some evidence for the unconscious inference. Okay. And 10, consider the 2013 article by our own Dr. Harry Heft entitled An Ecological Approach to Psychology, and maybe you can talk about animal-environment reciprocity. Okay, so if you can work on those couple of questions. Then folks here who are center-ish, can we put you on questions 11 and 12? Okay. Consider the article again by Dr. Heft, and maybe you can summarize a subsection entitled The Meaningful Environment Affordances. Okay. Very interesting idea of affordances and what is meant by that in the context of perception. And question 12 also, if you can come down here from the same article and talk to us about his views on change and action. Okay, so you have affordances, change and action from that reading. Okay. And then folks over here on the window-ish side of the room, I wonder if we can have you do, we've already done question 13, so I wonder if we can have you talk about questions 14 and 15. We can talk a little bit about proximal and distal stimuli, and Meg began to allude to those earlier. So proximal and distal stimuli, how are those different from each other? And then maybe you can talk a little bit about this idea about the checkered shadow illusion by Ted Adelson of MIT. By the way, a fairly recent graduate from this class spent some time working in Ted Adelson's lab at MIT. Her name is Jenna Kelly, and maybe Jenna will be joining us by Skype later this semester. Okay, so the shadow illusion and whether we think it's more reflective of structuralism or unconscious inference. Okay, so everybody's got a pair of questions. Please feel free to go ahead and mix it up. I'll keep projecting these, and we'll come back and check in just a couple of minutes.
explains that I had. I just had to read them. A lot of different things. I just felt like it was like big. Like the actual a lot of it like so like the perception of other people like I can't remember exactly what to say.
The other one was the subsection of the one article about the animal environment.
I just like so I were maybe like I basically like hence why perception is taking that so then as part of the conversation that's why I
Well, I just like open them back up and even though I already answered them, I just like add those together.
that was that's
Yeah, so I promise I did
I just don't think it relates.
exactly. Sometimes like if I like can't also say that I'm like just think about something like totally let's just do like spelling. It doesn't work. I don't know.
Okay, in the interest of time, why don't we come back together and see what kinds of things people have done. Who remembers doing different Gestalt principles in Psych 100? Do you remember seeing a whole bunch of that? And there's, we could spend a lot of time on these. I think this works pretty well. Claire's given us an example of proximity, right? So it's almost like visual chunking. Who remembers chunking from Psych 100? Okay, that's something that we learn about in memory. There's an analog over here in the world of perception. We can say, well, here's a chunk, here's a chunk, and here's a chunk, and we tend to group by proximity. And there are lots of different ways of thinking about these Gestalt grouping principles. One of the things that people would sometimes say about this, being critical, is, at least in their early time, it was almost as if they were engaging in the phenomenon of explanation by naming. So the notion would be this, that, well, it looks like that groups, and it looks like that groups, and it looks like that's a group, but you haven't really explained anything by calling it grouping. We've given it a name, and now I can go to Jess and I can say, oh, let's create an example of perceptual grouping by proximity, and we can probably do that. It doesn't really, though, explain why our visual system breaks those things down the way that they do. There was never an attempt to maybe understand the physiology of all of that. And to be fair, they didn't have many of the tools that you and I now have. But in any event, they were astute observers of how things were grouped, and they did try to give some names to these things, and that was helpful to get the ball rolling. Okay? All right, so let's go back over to 9 and 10 and see what folks on the door side had to say about the unconscious inference. Anybody want to help us out with that? Okay, thanks, Gabby.
We talked about how unconscious inferences are like reflexes, and it's a reflex like mechanism that decide on how
Okay, right. So lots of terminology in there. Gabby is invoking the word decision, and that's I think something that's fairly appropriate here. Right, we're making a decision about what we see. There's some uncertainty, and we have to make some kind of a guess, and we're not even aware that we're making that guess. But there's sometimes a very ambiguous stimulus, and it's kind of like that situation for multi-stability. Right? There's one stimulus that can have multiple interpretations, and we might have one interpretation at one moment, another at another moment. It is based, I think Gabby also added that it was based on probability, that for a given stimulus, certain interpretations are more probable than other interpretations are. So what's interesting about this is we're back to trying to reduce the uncertainty about what's out there in the world. Okay, so we'll talk first about a definition that I hope you'll jot down. I learned this from one of the folks at a lunch visiting our department a few years back. This person defined information very simply as the reduction of uncertainty, which I think is a great definition. It's very succinct. Okay? What is information? The reduction of uncertainty. Your professor provides you information about the upcoming exam on Friday. Well, how many points is it worth? What's the format? What's the content? What range of things should we study? They're reducing the uncertainty. You could have a professor that says absolutely nothing about that and just shows up and hands you the exam. You would have a lot of uncertainty about what was going to be on that. So we're looking to reduce the uncertainty because we actually need our perceptual systems to navigate around the world and to navigate through the environment. Now, one approach would be a very bottom-up approach. Who remembers hearing this phrase from Intro to Psych? Okay, and one of the simple phrases that we can use to help us understand what we mean by bottom-up is stimulus-driven. This is very structuralist. Everything that you need is right there in the stimulus. Okay, and if we understood fundamentally what was in the stimulus, then we could string those together, and their sum would tell us really what our perceptions are. Okay, so everything that we need is very much right in the stimulus. It's stimulus-driven. We don't need anything beyond that. In Gabby's excellent answer to the unconscious inference, she said, well, we make a decision. Okay, now the decision is interestingly not a part of the stimulus, right? The decision is in our brains. We make a decision based on some probabilities. Well, where are the probabilities? Interestingly, you can imagine that you could have probabilities in your head, that maybe you have a particular set of neurons that are well and strongly wired together, and that particular combination basically represents a probability that certain stimulus configurations are more likely than others. So maybe by some combination of bottom-up stimulation and some idea about what is likely and what is unlikely, that drives our perceptual experiences, and we get this unconscious inference. We infer that something is there because of what we know about probabilities. Who's following that? Is it working for us? Okay. So it's not just all about the stimulus. There's some kind of interaction between what we expect, that's top-down, knowledge-driven, and what is available to us at the level of our sensors. Okay. All right. Can somebody help us out with the animal-environment reciprocity? It's a very important idea inside of ecological psychology. Animal-environment reciprocity. Okay, thanks, Meg.
Kind of how where the environment in which the animal inhabits kind of allows it to have certain possibilities and also gives it some constraints.
Okay.
So like the environment kind of affects what the animal can do versus when like specifically how the animal affects the environment.
Okay, right, yeah, and this is an important idea, this animal-environment reciprocity, when we think about how to approach the study of perception, and we were trying to understand what is the organism doing, which might predispose us a little bit toward that organism's brain, and what's going on in the environment, right? So the two answers to the big question for the day, why do things look as they do? Well, the world is as it is. It's a very environmental-centered response, or the brain is as it is. But here, these folks are talking about the reciprocity between those. We're going to spend a lot of time this semester talking about evolution and how our eyes and ears evolved, seemingly from almost nothing, just very rudimentary matter. How did we go from rudimentary matter all the way up to a remarkably complicated auditory system and visual system and so forth? But it turns out that the environment did a lot of selecting along the way. Okay? Environments impose a lot of constraints on what organisms get selected to survive and to sexually reproduce and so forth. The organisms themselves go about changing the environment from time to time. And so there's this reciprocity between the environment doing the selecting of particular organisms and those organisms changing their eco-niche. They're changing what's going on in their environment. Okay? All right, what do we have? A couple more minutes. Why don't we do this? The students usually really like this crazy fire illusion, and we'll just have you take a look at it and then maybe muse about it. I apologize if you've already seen this one, okay? But I think this is about 1 minute really, really well spent. Okay, the amazing fire illusion. Pretty cool. Some thoughts on that. How many people have seen that one before? Most of us hadn't seen that. Okay, that's good. So that was something new. Some thoughts on that. Interesting perceptual experience, right? Just to begin to tie that to the ecological approach, there are a couple of different ways we can connect that. But one is that in the ecological approach, a recurring theme is that our perceptual systems are for action. And it's going to be one of the questions that comes up later. They're for action. And one of the ways of thinking about that is that, as we've said, our perceptual systems are very metabolically expensive. Eyes demand a lot of oxygen. They demand a lot of resources. So why would evolution give us that kind of a burden? You know, once we have eyes and once we have brains, we need to feed that stuff, right? Okay, and actually we need to engage in feeding prior to that evolutionarily, but still we have this really, really big demand. Well, it must be the case that the eyes are paying for themselves. If we can see very clearly, or at least clearly enough, we can begin to navigate our environment and extract energy from the environment, extract matter, and turn that into energy that we can use, such that the eyes actually wind up paying for themselves evolutionarily. And here, one of the things we get is that there can be a great limitation if you only view a stimulus from one particular vantage point. If you move through, you can reveal lots and lots of different kinds of information about the environment, and your perceptual experience changes dramatically with your motion through the environment. So as we see when we'll come back on Wednesday, there's a bit of a tension between some researchers who study perception by sitting in a lab and flashing stimuli on a screen without requiring that somebody move through the environment and interact and reciprocate with the environment, versus another set of researchers that study perception and action simultaneously. Okay? But more on that on Wednesday. I like to start on time and end on time. Thanks for a great session, and I look forward to seeing some of you in just a couple of minutes, or at 4:30 today if you're a neuroscientist, or at 4:30 tomorrow if you'd like to see Dr. Maureen Craig's excellent presentation on social psych, and then I'll see everybody back here on Wednesday. Have a great day.